Okay, so this diagram shows a typical setup where you have an HF receiver that is outputting the FSK audio tones to the audio input of the Harris modem. And this audio signal is representative of Bordeaux code and 45.45 baud. Similarly, the output of the HF modem, the audio output, would be sent to an HF transmitter, the input of an HF transmitter. And again, the audio would need to be in Bordeaux and 45.45 baud. And these signals in and out get translated. On the bottom, you see it get translated to RS-232 signal levels, electrical signal levels from audio signals. And that gets sent to a computer or a terminal. And again, in a typical setup, this would be Bordeaux and 45.45 baud. Now, this is a typical setup. The problem that we have is that there are no more computers or terminals, not easily accessed anyway, that will handle an RS-232 communication at 45 baud and with the Bordeaux character set. So what can we do about this? Well, this is what I've done. Okay, so we've introduced a new box in here called the black box CAP or CAP, which stands for a communications adapter. P means plus, the marketing thing. And what the point of this device, which I will show a picture of, is it will convert two things. It will do a translation of the character set from Bordeaux, from the modem, to ASCII that the computer needs. And it will also do a translation of the baud rate from 45 baud to 9600 baud. And armed with this additional component, we now have a complete system. But getting this black box CAP up and running was quite the sub project here, and I'll just give you an example of what it's all about. So here is a picture of the black box CAP with the top off, and also to the left of it you can see a pretty standard USB to serial adapter. In this day and age, you need these USB serial adapters to do serial communications with the PCs. Now, what you can see here there are 1, 2, 3, 4, 5, 6, 8 position dip switches, and one or two other jumpers, all taken. So you've got there's a lot of different options here. 7. What did I say it was? 2, 4, 5, 6 times 8. 48 different possible, or 2 to the 48 possible combinations here. Luckily, I have the manual, and so we can make some pretty educated guesses about how all this ought to be configured. But let me tell you, even with the manual, this took days to sort out all the details. Let me show you the final configuration that worked for us. Each of these, this is a spreadsheet that I put together to document at least this particular working configuration. I suspect there are other configurations that would work too, especially some of the items on the right-hand side. But this is what's currently working, and so I wanted to document it. So each of these 6 boxes represents one of those 8-bit dip switches, and of course you can see, if you go down, you can see what each bit is set to, off or on, and what the meaning is. So if we look at this, we can see, for example, switch 1 for the port A, which we've arbitrarily assigned the computer to, and switch 3, you can see below it, are all the channel configuration details for that port. Again, we've assigned that to the computer arbitrarily. And so you can see 1 stop bit, we've disabled parity, 8 data bits, hardware flow control, 9600 baud, and the ASCII character set. Similarly, if you look at S2 and S4, you see 1 stop bit, 5 no parity, 5 data bits, hardware flow control, 45.45 baud, and the Bordeaux character set. And the system will then, of course, translate as it moves data from port A to B or from port B to A, it will translate in the correct direction. Just one thing I'll point out on the right, there are a few other parameters to be set, a lot of which I don't frankly understand or know when I've set them exactly what they mean. The documentation is really quite poor in this regard. But I will mention, if you look at in blue, there are settings that the documentation leads you to believe that you can change a port from data terminal equipment to data communications equipment. And this is the difference between whether the transmit signal goes to from one machine goes to the receive signal of another, or whether they sort of butt heads and is straight through or crossover. And I spent hours and hours trying to make this whole thing work, figuring this might be an issue, switching it back and forth. It ends up that this does not have any bearing on whether or not the unit is set up as DTE or DCE. So I don't really know if what I've said is correct, but it does seem to work. The other parameter I'll point out here is on the right in orange, which is the RTS. What this setting does is, instead of waiting for the user to assert the RTS line to get the modem to start generating audio and to key the transmitter, we're doing this automatically. So this setting of the communications adapter means that it will automatically assert the RTS line when there is data being sent to the modem from the laptop or from the computer. And so this kind of automates this sticky issue of some external line that the user has to manage to get the thing to generate audio and transmit. So it's a very nice setting in the communications adapter, and we're making use of it. Okay, to start off, we're going to just do a test in one direction, which is a received audio to the computer. And then we'll do the transmit test later. Now this is again what a typical setup would look like for this, where you're using an HF receiver. Now, to make this testing as easy and as few variables as possible, we're going to take a little slight detour here, and let me show you that. So instead of using an HF receiver and trying to tune in some RTTY somewhere that I may or may not be able to get to hear well, or propagation, instead what we're going to do is we're going to use a service on the internet called ITTY, ITTY, which is, instead of radio teletype, it is which is RTTY. This is ITTY, Internet Teletype. Now what this is a service run by a fellow out in Colorado who allows people to upload news stories, general interest stories, text, even RTTY art up into his system in the cloud. And then he translates that all, it takes that data and makes an audio stream, just like you would go on Spotify and stream your favorite song, your favorite music. He is doing an audio stream of this FSK data from these news articles. And it's very easy to go to. You just point your browser to internet-tty.net port 8000/ITTY, and you will immediately start hearing a stream. And this is what this stream sounds like. Okay, so you get the idea. And that audio will come out on your laptop, and if you have speakers, you can hear it just as what you heard. We're going to feed that audio using some cabling out of the laptop and into the audio input of the modem. Then we will take the serial output of that modem, pipe it in through the communications adapter, which will convert it to ASCII and 9600 baud. And then we will use a terminal program on the laptop, PUTTY in this case, PUTTY, using a serial, connecting to the serial port, and we'll see what the data looks like. So I think this is where things start getting exciting, where the rubber meets the road, and let me get this set up, and I will show you exactly how it all looks. Okay, good morning. It's December 31st, the last day of the year, and I'm putting the finishing touches on this video. So in this part of the video, we're going to look at the whole thing set up for a receive trial to see if it can receive and decode and convert from Bordeaux to ASCII and all that good stuff and see if the system works. So let's run through everything that we've got here. So on the laptop here, you'll see, if it'll focus, we've got a browser open to the ITTY, the ITTY audio streaming service. And when you go there, I'll hit play to start the stream, and you'll see what you hear. All right, just like what I demonstrated earlier. Let's pause that so we don't go crazy. And what I'm going to do here is I'm going to connect. I have this cable that's got an 1/8 inch jack, and which then connects to an XLR cable. And then this XLR cable goes to the back. And this is from a previous video. You'll recognize this. And that's going into here, channel A input. Okay, channel A input then goes to one of these two DA15 jacks. And then we have RS-232 coming out of this jack, and I'll just point out, see if I can get a good shot of it. I don't know if I can get a good shot of it. Maybe that wasn't so bad. I had to use, let's see, can I do this? Yeah. I had to use a 25 pin to 9 pin adapter. So here's 25 pins. But on the other side, I happen to have this 9 pin cable. So I used just a straight adapter, and not even a gender change. Okay, that then goes into, here's the cap, this is the communications adapter, goes into port B. And this will be the Bordeaux and 45.45 baud going into port B for translation. And then on this side, we have this little orange adapter. This is a null modem adapter, which means it switches RX and TX, receive and transmit data, and also reverses some of the handshaking signals to work. Then we've got this USB to serial dongle, and we can follow that along, and that goes right back into the laptop USB port, and ultimately it will go into a terminal program. Okay, so let's get things started up and let's see what happens. So first we're going to start the terminal program. I happen to be using this tool called Putty. Not really focusing too well. Putty. And I've got it default set up a couple of different settings. So let's load this one. And you can see here that it's set to COM port 9, which is what the USB COM port shows up as. And you'll see here 9600 baud and serial settings. And there's somewhere in here you set up the details. But let's load it and open it. Okay, let's clear this. This is from an earlier test that I did. Reset the terminal. Okay. And let's make it nice and big. Now, the next thing we have to do, sorry, I don't know if you were seeing all that. The next thing we have to do is get the ITTY up and running. Okay, so that's up and running, producing tones, and let's shrink that down. And then the final thing we have to do is to plug in this audio connector to get the audio going to the modem. And so let's do that right here. Okay, the audio is turned off, and as you can see here, it is now decoding ITTY. A few other things to point out here is you now see a signal presence on channel A. And in fact, I'll set the meter to show the input levels of the mark and space frequencies. And what I'll do is I'll adjust the using the keyboard, I'll adjust the volumes, and you'll see how this is affected. So I'm going to go down in volume. Okay. And you see there's no longer a signal presence because I actually just muted the laptop. And as we go up in volume, there you can see a signal presence, and as I increase it and increase it and increase it, you see the bar graph increasing. O probably means overload is my guess, the little O on the right. So let's lower that a bit to that. And that's great. And so let's take a look at this. So here we are. We are decoding teletype. Not much to say about it other than it's just some random news story or special interest story. Works very well. And then finally, let's take a look at what's going on here. And what you'll see is RX-B. So port B is the one connected to the modem. And that's getting a lot of low speed traffic, 45 baud traffic. And you can see that the light is turning on and off more slowly, whereas the TXA means you're receiving data into the 3466 modem and then sending it out to the laptop. TXA, it's port A's laptop. You see, the A is blinking very quickly, and that's because it's at 9600 baud. So any given character coming in at 45.45 goes out very, very quickly. And that's basically it. That is the receive test. Not much more to show. That is the receive test, working very well. And the next test we're going to do is a transmit test, and which is a little bit more involved, and I'll explain why. But overall, this is great progress. All right, so let's do a transmit test now. First thing we're going to do is just produce audio, and let's see how it works. And let's take a look at how it's configured. For this setup, it's a lot simpler. For this setup, we've got PuTTY running, and it's running on COM port 9 with 9600 baud. And in this case, all we have is the USB to serial, and it's just going into the same configuration I showed previously. Then what we have is in the back, I just have here, you've got channel A out, and I've got a little XLR cable, and that XLR cable is just running to a speaker. I have here a little powered speaker so you can hear the results. It's not yet connected to the transmitter. We'll do that test next and see how that goes. And so we've got set up for standard RTTY, and hopefully you can hear this. Let's give it a whirl. Let's see what we got here. Let's see if I can get it to focus. That would really be nice. So as you can see, as I type, you can hear it. And if you type fast, because of the buffering of the black box communications adapter, it continues to go. So here you can see the buffering occurring. And then on here, what do we see? What you're going to see here is that channel A send light will go on. It's a little delayed, but it does send. And once you stop, send light goes off. And I'll show you in the next part of this video where we connect it to the transmitter how this actually works. And we end up with like kind of a QSK, a full break-in capability, or maybe it's called semi-break-in, I'm not sure. So the other thing you can do is while you're transmitting, not that you would ever do this, but we can listen to what the different RTTY modes sound like. So here is RTTY high, switch it to RTTY low tones. You can switch it to the 2000 center frequency and 850 shift. And you could even do other things. For example, let's hear what this sounds like. I just sent a single character. That was a single character. One more single character. Okay, I think there's some sort of a preamble or some other stuff going on there. Let's try robust serial mode. Again, let's see, one character. Yeah. That's a long one. A single character. Wow. Wow. That's a long one. Oh boy, that was a single character. Now, of course, if I had sent 2 or 3 characters, it probably would not have been any longer than that or much longer. And then, of course, FSK you can play around with. And then the combinations. Yeah, so that's basically it. You can hear it works very well. Oops, did the wrong thing. Let's go here. And the next thing we'll do is let's hook it up to the exciter and the transmitter, and see what we can see. So we now have the entire transmitter up and running and set up. And what we've done in the back here, forgive the vertical nature of this, but it's the best way to do it. So here what we have is the output here. The output of the modem, the audio output channel A, is going directly in to here, which is an auxiliary input. We could have done any number of different inputs, but we chose to use auxiliary 2. Okay. And so what we'll see is one thing to keep an eye on is the key line, and hopefully you could also hear the audio. If you watch this key line light, you'll see that it's transmitting when I press a key. And then when I stop, give a few seconds, the key line will release. The reason this is happening, let's put this on, save a little fan noise. The reason this is happening is because I'm using Vox, which is a Vox keying, which means that when there's audio in the channel, I should have also pointed out, I've got the exciter set up for AFSK, auxiliary 2, which is the input I showed you before, and minus 10 dB output. I don't need to put a kilowatt into my dummy load for this test. And so when it hears audio on the auxiliary 2 line, when that audio reaches a certain threshold, it will automatically key the transmitter. So in this respect, it just makes it a little simpler from the computer's perspective. And again, you can see, well, let me turn this thing back on here. Let's go to operate. Okay, and you can hear it as I type. Now, the other thing we could look at, see if we can do this simultaneously, I don't know if we can, is to look at my station monitor as I key up, see if I could do this. And what's really great is that this is behaving in a sort of QSK manner, which means that every time you see that blip of data, of RF, that the TR relay is putting the transmission out to the antenna, and as soon as this key line, where is it? As soon as the key line turns off, it goes back to receive. 1, 2, 3, 4, 5 seconds. It's actually faster than that when it gets going, but so this is generally it. And there's going to be one more, I think, 1 or 2 more parts to this, but I wanted to show the whole system sort of working, both receive and transmit, and how the keying works.